Okay, so let's, we're going to do the relative rates of nucleophilic substitution, and right now I'm doing part A, which is determining the factors affecting the rate of an SN2 reaction. So what we're going to be doing is we're going to, I've got sodium iodide, 15% sodium iodide, and I have put 2 milliliters of sodium iodide into each of these 3 containers. Into the first, I'm going to put 20 milliliters of 1-bromobutane. Okay, so 1-bromobutane, and I'm going to put, you can see it here, 20 drops. 1, 2, 3, 4, 5, 6. All right, I'm going to stir it up a little bit, put it back in there. Then to the next one, I'm going to add 2-bromobutane. All right, and then to the third one, I'm going to add 2-bromo-2-methylpropane. All right, and then it says to just let it sit, to stir them up a little bit. And then to let them sit for about 10 to 15 minutes. So we're going to come back and look at these in a minute, but I want you to see that the 1-bromobutane has already started clouding up. A little bit hard to see, but compared to the 2-bromobutane, you could definitely see it's clouding up. So we'll let it sit there for a little while and see what happens. And I'm going to go on to the second part, the effect of the leaving group. So I've done the same thing over here, and I have, I've put 2 milliliters, let's move the camera down. I put 2 milliliters of the 15% sodium iodide, which is in acetone. And so I put 2 milliliters in each of these 2 test tubes, and now I'm going to add 20 drops of 1-bromobutane to the first one, so that'll repeat what we did over here. And then 1-chlorobutane into the second. And remember what's happening, we're looking for a precipitate, because what's happening, we've got the sodium iodide in solution, and the iodide is going to replace either the bromine or the chlorine, whichever one. Now sodium iodide is soluble in acetone, but sodium chloride and sodium bromide are not soluble. So as the leaving group leaves and the reaction takes place, the precipitate will form, because you'll have either, if it's bromo, it'll be sodium bromide, and if it's chloro, it'll be sodium chloride, and so that is the precipitate. So a precipitate indicates that a reaction is happening. All right, so I'm going to go over here, and I'm going to put 20 drops of 1-bromobutane into this first one. Get some more. All right, and then I'm going to put 20 milliliters of 1-chlorobutane into the other one. So again, we need to stir these up. Got a cork for both of them. And what you can already see here is that the 1-bromo is already getting cloudy, and maybe a little hard to see here, but the 1-bromo is already getting a little cloudy. That's the one on the left. It's already getting a little cloudy compared to the 1-chloro. All right, well, I'll pause for a little while and then we'll come back and look at them in about 10 minutes. All right, so I have let it sit for about 10 minutes. And what you can see is that, let's see if I can get it. This is the 1-bromobutane. This is from part 1. So this is where I did 1-bromobutane, 2-bromobutane, and 2-bromo-2-methylpropane. So you can see that the 1-bromobutane, and if I let it sit for a minute, you can actually see the precipitate sitting there on the bottom. So there's lots of precipitate in the 1-bromobutane. The 2-bromobutane is just slightly cloudy. It's gotten a little bit cloudy. I don't see any precipitate in it, but I do see that it's cloudy. So I think if we let it sit a while longer, a little bit of precipitate might form. And then the 2-bromo-2-methylpropane, again, maybe slightly cloudy, but basically no change at all. So that was after letting it sit. Now let's look at the second part, which is the leaving group. So again, the 1-bromo-1-butane, you can see actually, let's see if I can get it in the camera very well. It's hard to see, but it's actually got a fair amount of precipitate sitting there at the bottom. If I stir it up, you can see it's very cloudy. The 1-chlorobutane is clear, still clear. So it means that no precipitate has occurred. So 1-bromobutane precipitated faster, or actually is the only one that precipitated. So the bromo, I'm not going to tell you what that means, but the bromo did precipitate, the chloro did not. So now I'm going to go ahead and set up the third part for part A, SN2 reactions. All right, so I've got this third part set up. In the left-hand test tube, I have 2 mils of 15% NaI, and I've added an extra 10 drops of NaI so that the volumes will be equal in the end. And then in the right-hand one, I have 2 milliliters of 15% NaI. In the left-hand one, I'm going to add 10 drops of bromobutane, and in the right one, I'm going to add 20 drops. So basically, I'm doubling the concentration in the right one. And then I'm going to try really hard to do it all at once. So 10 in the left, you can't see it, 20 in the right. And then we'll sort of let it see what's happening. I'm going to mix them up. Kind of watch what's happening. I know you can't see it. We're going to see which one precipitates first. And already I can see that the right one is going faster. I know it's really hard to say, well, so we've doubled the concentration. If I watch the time, it's not exact, but now the left one's starting to precipitate. So it's about, the one on the right went just about twice as fast as the one on the left. So the double the concentration went about twice as fast as the lower concentration. So that's pretty much what we expect from SN2, that if you double the concentration of one of the reactants, you double the rate. And that's pretty much what we saw. So now I'm going to do the same thing over here, but do in the opposite direction to check on the concentration of the NaI. So in this case, I've got 1 milliliter of bromobutane in each of the test tubes. And in the left-hand side, I'm going to add 15% NaI. And in the right-hand side, I'm going to add 7.5% NaI. And so what I did is I just took about a milliliter of the 15% and I diluted it down with water. So this concentration is about half as concentrated as the other one. And so in this case, let me see my directions. I'm going to add about 20 milliliters of each of them. I'm going to try at the same time. So again, this is where it's helpful to have a partner. But I'm going to add 20 to each of these. All right, and hopefully, since it's a kind of a slow reaction, oh, look at that one on the left, already precipitated pretty quickly. The one on the right is taking a little bit longer. Oh, you know what happened? Shoot. I diluted it with water, and I should have diluted it with acetone. So let me try that again. All right, so if you have kind of already studied the SN1 and SN2 reactions, you'll know why the fact that I diluted, I had my 15% NaI in acetone, and then I diluted it half to make the 7.5, but I used water. And if you know anything about SN2 reactions, the water doesn't work. The acetone is a aprotic solvent. So let me try this again. I've got 1 milliliter of 1-bromobutane in each of these, and I'm going to add 20 drops of 15% to the left and 7.5% to the right. A little bit difficult. It's hard to see. They both went very quickly, but I would say the one on the left, this one might be harder to say which one went faster. The one on the left went a little faster, the 15%, and also if you look at the amount of precipitate that formed, the 15% has about double the, oh, I'm not showing it to you, there we go. The one on the left has about double the precipitate that the one on the right does. So the rate of the reaction seems to also hold. It's not perfect. This isn't the perfect way of measuring it, but again, it seems pretty much that when we doubled the concentration, the rate also doubled. And so that's characteristic of an SN2 reaction. All right, so let me, I'll stop here for part 1. And then there'll be another video for part 2, for part B.